students, 11 students. If anybody would like to ask any question, or anybody would like to revise what we have done last time, what was the topic? क्या topic क्या था last time? So I have shared my screen and I will start recording also. So anybody will like to review last lecture? So for record purpose, this is class of hydrology and water resources in civil engineering. Today is 15th of December. This is section B. So before more student joins in the class, there are only 16 at the moment. I would like that if anybody would like to ask any question from the last lecture. The last lecture.
Sir, I'll
जी बोलो.
albedo से ना आइडिया दोबारा दे दें सर albedo इफेक्ट का.
मैं सदके जाऊं तेरे. क्या दे दूं आइडिया?
albedo इफेक्ट का ना थोड़ा सा ज्यादा बैर से एक्सप्लेन कर दें.
सिर्फ मुझे उसकी डेफिनेशन बता दो फिर मैं एक्सप्लेन कर देता हूं.
सर वो रात को बैठ के थोड़ी सी देखी थी उसके ऊपर
वही ना, सिर्फ उसकी डेफिनेशन देखने
नहीं आई
वाली
थी albedo इफेक्ट पे.
सिर्फ उसकी डेफिनेशन देखने वाली है. ओके, मैं कहता हूँ किसी दोस्त से आपके कि बताए. एनीबॉडी वुड लाइक टू डिफाइन अल्बीडो? रेज योर हैंड प्लीज. हमजा नियाज जी प्लीज. बिल्कुल सही है. रिफ्लेक्टेड एनर्जी और इंसिडेंट एनर्जी का रेशियो. तो that shows how much energy is reflected. If it is equal to 1, it means 100% energy which is coming to that surface is being reflected. And if it is equal to 0.5, it means 50% is reflected, 50% is absorbed by the body or transmitted through the body. So, is there any more clarification needed? क्या नाम था जिसने सवाल उठाया था?
सर मेरा था मोइन अवैस.
मोइन अवैस. तो ये रिफ्लेक्टिव इंडेक्स है, यूं समझ लो, या रिफ्लेक्टिव कोएफिशिएंट है. इट शोज एनर्जी रिफ्लेक्टेड with respect to energy incident, and it is related with the color which we perceive of a certain surface. We say that the sun is giving us light of different colors, of different wavelengths, and in combined they seems to us as a white light. Actually, if we see them in small spectrum waves in small bands, we will see part of it is red, part of it is green, part of it is blue, and other wavelengths also, infrared, which we cannot see. So if a body reflects all the energy it is receiving, we see that it is whitish. So we say this is a white body. Because evaporation is dependent upon the energy received by the energy absorbed by the surface or the water or the surface containing water, evaporation is dependent upon energy of the water. So albedo coefficient was introduced to you. Those bodies which have high albedo coefficient, for example, कोई बताओगे कोई ऐसी बॉडी जिसका albedo हाई है? कौन सी बॉडी है? The highest albedo which we saw in our lecture was that of fresh snow. Fresh snow. So it means
Yes, sir.
snow is not absorbing much energy. Means it don't have much energy for evaporation also. So that's why it has been seen that evaporation from a snowy surface is less as compared to evaporation from a soil surface or evaporation from a water body. Reason is available energy, and available energy reason, different available energy reason is different reflective coefficient. So that was about albedo. So only definition need to be known to you. You would have understood it. Okay, so now we are 22 students with us. I think section B तकरीबन इतना ही होता है. Let us, if anybody have question, you are still welcome. Thank you, Moina Wes, for asking question. Hanji. Thank you, Hamza, for answering the question. So today lecture is about stream gauging. I think I have shared with you these lecture already. ये stream gauge के lecture मैंने share कर दिए.
Yes, sir.
Okay, so two files consist of this topic, stream gauging. In this file, I think we will be talking about stream gauging part related to water level measurement or stage measurement in the stream. When we will be starting the next file or next presentation, maybe this week or maybe next week. So that will be related to how to measure the discharge flow rate. Stream gauge is related to both of these. So any gauge which is installed on a stream, we say this is a stream gauge, and stream gauging is the topic or the discussion related to measurement of different parameters on the stream. Different parameter on the stream can be which are related to us. क्या क्या हो सकता है हमारे related, क्या हो सकता है stream के ऊपर हमें क्या क्या interest हो सकता है. In this figure you are seeing a stream, a channel, and there is a gauging station over there. We call it seems to be a weir like structure which is used to measure that flow rate also. So I was asking what parameters are of interest to a hydrologist or to a civil engineer on a stream. कौन से पैरामीटर हैं जो हमारे इंटरेस्ट में होते हैं? तो स्ट्रीम गेज इज रिलेटेड टू मेजरमेंट ऑफ दोज पैरामीटर्स. एनीबॉडी? कौन कौन से पैरामीटर्स?
स्टेज और डिस्चार्ज.
एक स्टेज हो गया, एक डिस्चार्ज या फ्लो रेट हो गया. एनीबॉडी वुड लाइक टू ऐड? सिर्फ ये दो ही होते हैं या कुछ और भी आप इंटरेस्टेड होते हैं?
सर सेडिमेंट्स वगैरह भी हो सकता है इसमें.
बिल्कुल हो सकता है, बिल्कुल हो सकता है. सेडिमेंट हो सकता है, वाटर क्वालिटी हो सकती है. तो when we are saying stream gauging, it means some instrument which is installed on a stream for measurement of different parameter. Most important parameters which most of the stream gauge station have is stage measurement and discharge measurement and sediment measurement, and nowadays water quality parameter is also getting more and more importance, so those are also being measured. So this lecture will be talking about how to measure these parameters. If you are a person who is related to a department who is interested with the job of measuring the stream, measuring the parameters related to stream, then you will be selecting the stations also. If you are a person in WAPDA or if you are a person in irrigation department, you are in charge of getting data from a certain stream or certain area, all streams of an area, then you will be selecting location of the stream also, stream gauge station also. So there are different parameters which you should be knowing that when you are selecting a stream gauging station, location should be of this kind, this kind, this kind, this kind. So that will be introduced to you. And then different method of stage measurement and different method of discharge measurement will be informed to you. Some method you already know. Stage measurement is simply measurement of the depth of water or level of the water in the stream. So that will not be so high. Different staff gauges will be informed to you. So maybe you feel that this is very simple, but there are certain certain SOPs which you need to follow when you have to install a stream gauging station at a location. Why we are interested in measurement of these parameters is mentioned over here in this slide. Uh, and this have been informed to you many times why we are studying hydrology, because we want to measure the water on the surface of earth, because we want to study the hydrological cycle. So, and why we are studying civil engineer, because we need this data, we need these parameters for design of our projects, for design of our bridges, for design of the culverts. Uh, People will ask you, design a bridge, design a road. So when you will be constructing a road, and if a stream is crossing it, people will expect from you that you will be deciding the size of the crossing, size of the culvert over there, size of the bridge you will be deciding, elevation of the bridge you will be deciding. So who will help you then? Then this will be hydrological data will help you. How much flow is expected at this location? So how much is the water level observed in the previous floods of last 30, 40 years? So from where this data will come? So any stream gauge which somebody has installed on that stream 30, 50 years ago, if it is there, that will help you. If it is not there, you will install a new stream gauging station over there, and you will be having then data of very limited time period. Then you will be using the scientific method to extrapolate those data. So stream gauge are quite important. They are the main source of information or data which are related for design of hydraulic structures. Basic data we get it from the stream gauge. Although we have alternate options available, but those are just estimate. Exact value of water level for a certain discharge can come only from a gauge station. If I use some formula to estimate what will be the water level if discharge is so much, then that is an estimate that may vary from time to time. So basic data we get from the stream gauges, so they are quite important. Hundred of stream gauges are run in the country, in Pakistan also. If I tell you the largest department who is looking after the stream in the northern part of Pakistan is WAPDA. They have a special directorate, they call it Surface Water Hydrology Project, SWHP, Surface Water Hydrology Project. They have installed stream gauge on most of the rivers, most of the tributaries of Indus Basin, especially those which are providing water to the dams and reservoirs and barrages. So they are constantly observing that data and recording that data so that anybody who need it in the later part of the in the later years, so they can get those data from WAPDA. And similarly, those structures which are available with irrigation department, they are taking care of stream gauge on those structures also. So in the upper Indus in Pakistan, surface water hydrology project is most suitable to get the data. And for barrages, it is usually the relevant irrigation department who is looking after the stream gauges. So generally speaking, discharge and the stage are two things which we measure. Why we measure importance of the stream gauging? Because we need water. for different purposes, and we already know the purpose, use of the water for energy, for irrigation, for navigation purpose. We need water. So quantification of this water and knowing the water levels and the discharge for using the water efficiently is must. So we need to measure the stream at different locations for all of these purposes, for water supply, for human settlement, for irrigation, water for plants. These are those uses of water which have been informed to you many times. Steam flow also sometimes cause steam flow sometimes cause flood also. So if we want to forecast the flood, we need to see the behavior of that stream in the historical events. We need to see the behavior of that stream. What do I mean by behavior? For example, water level or the flood level is dependent upon the channel cross section and channel slope. Same discharge in one channel may cause flood, and in another channel, same discharge don't cause flood. I give you an example that uh, flood, high flood in Indus River is about high flood in Indus River at Chashma starts from 5 lakh, 6 lakh cusics. 10 lakh cusic is exceptionally high flood over there in Indus on Chashma. But for Ravi, maybe flood start from 100,000 cusic. 1 लाख क्यूसिक पे यहाँ पे फ्लड हो जाता है. So it depends upon the stream size, it depends upon the slope, it depends upon the width of the river over there, or simply I say cross-sectional geometry of the stream. So to know the behavior of the stream gauge need to be installed so that we should know what will be the water level when so much flow will come, what will be the water level when so much flow will become, and how much flow is coming, both of these things. So these are the three data usually which we measure, and in addition to that, water quality parameters are also being measured by environmentalists or water experts. So this is a slide which highlights if you have to select a stream gauge station, a new stream gauge station, you should take care of these things. Uh, Initially, you should know what are the factors which are controlling the relationship between water level and discharge. What is the factor which is controlling the relationship between water level in the stream and the discharge and the flow rate? There can be two factors, and the factor which control this, we say Fida, but when you join the meeting, please switch off your mic first. जब आप मीटिंग ज्वाइन किया करो ना, तो अपना माइक स्विच ऑफ करके रखा करो. Okay. So control are, if we say hydraulic control is a special term which we use to know what thing is controlling the relationship between water level and discharge. What thing is controlling? So there can be two possible controls. One is some cross section or section is controlling the relationship between water level and discharge. Either it is a section or it is a stream. So either it is a section or it is a stream. So section example of sectional control is, for example, there is a fall. What is a fall? Sudden drop of level of the bed of the channel. Sudden drop of bed level of the channel. For example, in this figure, we can say that there is a drop of water over here. So in this figure, you can see there is a drop. So sudden drop in the water level, so that can cause a control over the flow rate and the discharge. So similarly, if there are rapids are the steep slope channels. Rapids are steep slope channels. So they can also control the relationship between water level and the discharge. So if there is a weir or there is a obstruction in the floor, that can also give us a control, and we call that one also a sectional control. So this relationship between stage and discharge is controlled either by a cross section, and the cross section can be a fall structure, it can be a obstruction like weir structure, or other possibility is that depth and discharge relationship is controlled by stream itself, by the stream itself. Okay, reach of the stream control. So what do we mean by reach? If there is no rapid, if there is no what we call it fall, if there is no obstruction, still there is a relationship between water level and discharge. Okay, so what is controlling that relationship? So if you remember Manning's coefficient, if you remember Manning's formula, V is equal to 1 over n r power 2 by 3 s power half. So that will tell you what are the parameters which are controlling the velocity and so the discharge. Those parameters which are controlling the velocity, because velocity is a part of velocity multiplied by flow area gives us the discharge. Q is equal to A into V gives me the discharge. So all those parameters which are controlling the velocity are controlling the discharge also. So when we say the reach is controlling the relationship, it means the Manning's roughness coefficient or simply the roughness of the channel longitudinal slope, shape of the geometry of the channel itself. So these things are controlling then the discharge stage relationship. So we should be clear that either a cross section will be controlling the discharge stage relationship, or reach will be controlling. These parameters are related to reach. Reach means length between two cross sections. Certain reach, 10 kilometer length reach, 100-meter length reach. So reach is the length of the channel, while cross section is a local location, one site. Cross section or section is one site. So if there are some structures like fall, like weir, so we say sectional control is there. And if there are some no such structures are there, then we say that it is a kind of reach is controlling, stream reach is controlling the relationship between discharge and stage. So whatever should be the control when we are selecting a stream gauge station, we should try to find a location where control is permanent. Where control is permanent means it should not be a temporary control. Arbitrarily, for example, there is an obstruction in the channel because of some debris, and we should not consider that this is a sectional control and I should install a stream gauge station over there, and after 1 month, after 2 months, that debris have been removed and that control has gone. So my station observation will be changed then. So control should be permanent. When you select a new gauging station, the control should be permanent. What do we mean by control? Either it is a sectional control or a reach control, whatever it is, that should be permanent. And if you have selected a station, for example, where stream is controlling, where reach is controlling the relationship, then that reach parameter should be constant. Means roughness should not be changing from month to month. It should not be like that in 1 month n is 0.01, in another month it is 0.03. So that will change the depth for the same discharge. So we will not be getting then correct information. Or for example, it should not be if reach is the control is by the reach, then slope should also be permanent over there. It should not be like that, that it is changing from month to month or year over year. Then relationship between discharge and stage will change. So that will change by observed data. So it should be, so that is one of the important thing, that there should be a permanent control should be there, and control is a special word which we want to, from which we want to tell that what is controlling the relationship between stage and discharge. Sometimes we install artificial controls like these dams, weirs, broad-crested weirs, or flumes. So these also called the control over the discharge stage relationship. They are man-made control structures. So there should be possibility that if we want to build such a control, stream gauging station should be selected at a such location that these can be constructed easily. So artificial controls can be built in a stream channel to stabilize relationship between stage and discharge. And what are the artificial artificial controls? Those are these low dams. Low dams means usually these barrages are called low dams. Dams with the what is a dam? Dam is an obstruction in the flow of water. Dam is an obstruction in the flow of water, usually built for storage of the water purpose. And because barrage also obstruct the water, so in this part of the world, in Pakistan, India, we call it barrage, but in other part of the world, in Egypt, in other, they call it as a low height dam, low head dams. They call barrages low head dams. So weirs are masonary structure built across the streams. Water flows over them, and they work as a artificial control to control the relationship between stage and discharge. Partial flumes. This is a special kind of flume. Flume is artificial channel, man-made channel. Artificial channel is flume, especially built in the laboratory. We call them as a flume. So partial flume is a special kind of flume, have a special shape. It contract the cross-sectional width. Partial flume contract the width of the channel and give it a steep slope so that a hydraulic jump is formed, and they can measure the discharge through this partial flume. So such structure we should be able to construct if we want to install an artificial control in the channel. So knowing the concept about control and the type of the control, here are the guidelines which you should be observing while you are selecting a new stream gauging station. It should be installed at a relatively straight reach. The reach should be straight. What is the other alternate? That we are installing a gauge station on a curved reach. You have gone to maybe northern area, you have seen the rivers, Kunhar river, and it is making many curves over there. Curvature is there. So we should avoid the location of the stream gauging station close to some curved part of the stream. At least 300 feet upstream and 300 feet downstream of the station should be straight reach. Reason for that is on the curvature, the water depth is usually higher on the outer side of the curvature, means on the convex side of the curvature. If you bring in your mind a stream, that plan view of a stream, it is having a curvature. So one will be the outer part of the curvature, one will be the inner part of the curvature, concave part, convex part. So on the convex part, usually the depth is higher, and on the inner side depth is lower. So we cannot have the same relationship. So if we measure the stage on inner side, it will be a few inches less. If we measure it on the outer side, it will be few inches high. There will be sedimentation or deposition of sediment on the inner part, inner side of the curvature, while there will be erosion on the outer side of the curvature. So these things limit us that we should avoid a stream gauging station on a curved on a curvature on a stream with a curvature. So we can find easily a certain length of the reach, about 600 feet length, 300, and we can install the steam gauging station on a straight reach as far as possible. Maybe you will not get 100% straight reach. Small variation can be accepted, but a large curvature should be avoided because it affects the water depth inside and outside, and it also changes the cross section because of deposition of the sediment and erosion of the sediment differently. On inner side it is deposition, on outer side it is erosion. The stream bed, when you are selecting a new stream gauging station, the stream bed in the vicinity of the site should not be subject to scour and fill. What does it mean? That is what I am sedimentation and deposition. We are calling scour and fill. It should not be wherever you select a stream gauging station. Over the year, that cross section should not be subject to considerable deposition of sediment over there or erosion of the sediment from there, and that will change the bed level of that section. If bed level is changed, for example, previously bed level was at 100 meter, and 100 cubic, 100,000 cubic flood uh, give me a flood level of, let us say, 110 feet. I repeat, for example, previously the bed level was 100 meter, and at 100,000 cubic flood give me a flood level of 110 meter. But if sedimentation has occurred over there and the bed have risen to 105 feet, 105 meter, then the flood level will also go up. So that will change the relationship between discharge and previously we would be expecting that 100,000 cubic flood will be coming with a water level of 110 meter. Now it will be 115 or more than that. So that changes are not known to the people. So we should avoid any cross section, any stream gauging station where excessive scour is there. Scour is removal of the sediment from the bed of the channel. Scouring is removal of the sediment, erosion, scour, and there should not be deposition or fill of the sediment. So those streams which are having high sediments and having low velocity, they cause sediment deposition. Those streams which have less sediments coming with them and they have high speed water, and they are moving at high velocities, they cause scour in the bed of the channel if bed has the scourable material. So we should avoid such places where scouring and filling is expected. Also, we should try to avoid any location where is excessive aquatic life is there, aquatic plants are there. Aquatic plants, there are some plants which grow in water. There are some plants which grow in water. So we should avoid such locations where growth of such plant is expected. Usually in the slow moving water, such kind of plant growth is there. If it is there, we have to continuously remove them. There should be permanent banks on the stream. If we have two sites available, one is having erodible banks, one is having very strong banks. So we should be selecting a channel which have strong banks, because stream channel quite often daily basis to measure the stage, to measure the discharge. So the bank should be stable. And the second thing related to this stability of the bank is because one of the requirement is that the cross sectional should also be stable. We should have a constant geometry of the cross section over there. So that also requires that the banks should be stable. We should have if we are interested, we should have opportunity to install an artificial control. If we want to build a weir over there, or if we want to build a small dam over there, or if we want to install a flume over there, then we should have this opportunity available if possible. No backwater effect from the downstream tributaries. There should be no backwater effect from downstream tributaries. Hopefully everybody know what is a tributary. Tributary is a channel which is providing water to another channel, to a main channel. For example, if some drain is joining Ravi River, for example, Lahore drains are joining Ravi rivers. So these drains are tributary to Ravi River. Ravi River is joining to Indus River. So Ravi is tributary to Indus. So tributary is a term we use in water resources to show a small channel joining to a big channel. So when we are selecting a stream gauging station, we should see that there is no backwater effect of a tributary which is joining on the downstream side. What is the reason for that? Uh, what is the reason for that? I will show you this on Word. अगर तो ये वर्ड चल गया या इसी पे दिखा देते insert align for example you have a river like this and a tributary is joining over here. So a flow is from top to bottom. If you have installed a station over here, insert shade. If you have installed a station over here, so it means you are interested to know discharge and stage of this channel. Okay, of the left channel in this figure, you are interested. So if there is a tributary coming over here on the downstream side of this stream gauge, and this tributary size is quite high, when it joins water to this place over here, there is possibility that this water goes up also in addition to going downstream also. So depending upon the channel slope, some effect of this tributary can proceed on the upstream side also. So we should avoid this location of the stream gauging station from such location where a downstream tributary can affect the water level of the stream gauge on the upstream side. So if it is the condition, and why we should avoid this? Because usually we measure the discharge by first estimating the stage. Usually what happens on the stream gauging station, we will study it later on, that daily basis we just go to the stream and we see what is the water level. We observe water level on daily basis or on hourly basis, and then we have the tables and the graphs available with us from where we convert that stage or water level into discharge. We convert it, and this relationship between stage and discharge is called as a rating curve, or if it is in a tabular form we call a rating table. So if I have measured a water level at this stream gauging station, and the water level at this location was wrongly increased because of this downstream tributary, the effect of this downstream tributary have risen the water level to higher elevation, it means I will be giving wrong message to the people that more flow is passing over here. Over here, all the flow was coming from this tributary. We will be giving the wrong information that this tributary is having higher flows. So that is the reason, if this is the case, we have to move this station either to the downstream of this confluence, or we have to move sufficiently upstream so that effect of this confluence point are not there. Either we move the stream gauge station much higher so that the effect of this confluence point does not reach over there, or we should move it down. So when we place it over here, this stream gauging station is placed downstream, we are measuring the discharge coming from both of these streams. And if we place it over here, then we are measuring discharge. So both is okay, fine for us. But if I am putting it over here close to the confluence and I am telling people that I am measuring discharge of only this stream, but actually the effect of these streams are also reaching over here. So that will be a wrong message going to the people, and we have to avoid that. So that is what the meaning of this possibility of no backwater effect from the downstream tributary should be there. So that is important when you visit a stream gauging station, which have already been constructed. You should see such things over there. If there is some tributary on the downstream side whose effect can reach to the stream gauge station, so then you can comment them. Okay, this is not a right location. You should change it. Stable cross section should be there. Stable metering oblique measuring section should be there. That is related to again sedimentation and deposition. The station at which we are measuring, that should be stable. It should not be changing its size or changing its cross sectional dimensions. So it should be stable. There should not be much debris and floating matter. A reason for that is if there is much floating matter over there, and one of the instrument which we use to measure the discharge, we call it as a current meter. The current meter is a rotating instrument. So if there is much debris, much floating material is there, it can damage current meter over there. So debris and floating matter need to be avoided. So if you have option available with you that there is a less debris station and a more debris station, we will be selecting a location where there are low debris and floating matters are there. The site should be accessible because you have to frequently go over there for operation, maintenance, and observation. It should have easy access. So those stream gauging stations which are located close to some existing road network, so those are preferred, because going to the station should not be a huge job. Going to the station and coming back to the head office should be an easy job. So also there should be power and telephone facility available at those locations. So one of the thing which we measure is stage. We can continue this from here and have a break for 5-7 minutes, and we can restart it. Now, if you have any question, that was important. Location, site selection for a stream gauging station. You should be understanding them, and you should be trying to implement them whenever you are site in charge, or whenever you are the person who has to decide the location of the stream gauging station. Okay, I take a break. I stop recording over here. After the break, I have again started the recording. And taking attendance sheet also. Download attendance list. Document downloads. So I can put it on the WhatsApp group. I share my screen. So I have put the attendance on WhatsApp. CR is requested to record it. Okay. Hopefully you are seeing the screen. So talking about important features of a good stream gauging station. Now we should move towards parameter which we want to measure. The first parameter which we interested is in stage. Stage in hydrology means elevation of water surface, and you know in survey elevation is with respect to a certain datum. Elevation is height of a place, height of anything with respect to certain reference level, reference point. So that reference line or reference surface is called as a datum, with which with which we measure the elevation of something. So elevation of a surface of water is called stage in hydrology. River stage is quite important. It tells me the flood level. It tells me how high should be a hydraulic structure if I want to construct it. So it plays important role in many civil engineering studies, in many infrastructure development studies, in many flood forecasting studies. Stage plays important role, so that should be known to us. Is measured. So when we mention datum, datum can be any arbitrary datum you have selected. Arbitrary mean out of your choice. If you have selected certain reference line as a datum line, so that's okay for you. For example, elevation of the table on which this computer is placed. If I want to measure it, I can have many datum for that purpose. I can measure the elevation with respect to the floor, so floor will be datum. I can measure it with respect to the road outside the department, so that will be working as a datum. I can measure its height or elevation with respect to mean sea level, so that will be working as a datum. So when you will be seeing the stage data, you should be knowing what is the datum that stream gauge operator has selected. That stream gauge owner has selected what datum. If it is a local datum he has selected, or he has selected it some country level datum or some international datum. So the GPS which you are using, GPS which you are using for finding the elevation of a certain location, so that is using international datum, international reference lines. So one of the international datum which is quite famous nowadays, they call it North American Vertical Datum. So NAVD. So NAVD 1988. So they have specified a certain spheroid, like there is a sphere of Earth. Earth is like a spheroid. So they have assumed a certain spheroid, and the mean sea level in the North American side. So they have selected that one as a reference line for that. Similarly, if it is a country level datum, for example, in Pakistan, we use Survey of Pakistan datum, SPD. Sometimes you will see stage or elevation measured above SPD, ASPD, or sometimes you will see AMSL, above mean sea level. So it means they are using mean sea level as a datum. SPD means Survey of Pakistan datum. Survey of Pakistan, they have fixed a certain datum. I think for Karachi mean sea level they have taken as the Survey of Pakistan datum. Or you can select datum or reference surface for your project yourself also. You fix a certain benchmark, and you say that this is my reference line. So all the other elevations will be measured with respect to this benchmark. So that is your arbitrary datum. So elevation measured with reference to a certain datum is called stage. Arbitrary datum plane for a stream gauging site. If you have selected the datum yourself, then you should select it in such a way that the lowest level which is of water which is possible over there, it should remain above the datum. If it goes below the datum, it means you will be recording negative values. So usually we avoid recording negative values. So because datum selection is of our choice, so select a datum sufficiently low level so that all the water levels or all the stages which are expected in that stream, that should come in the positive side. Just a norm, not mathematically required, but usually stages are above the datum. For each gauging station, maintain a permanent datum. While bed level do change to some extent by deposition and sedimentation, the stream bed do change. So, but your datum, the reference line, that should be permanent. You should fix some permanent benchmark close to your stream station. At least 3 benchmarks should be selected. Permanent reference mark should be selected. With reference to that, the bed level or the zero of your station should be known to you. For each gauging station, maintain a permanent datum that has at least 3 permanent reference marks that are independent of the gauge structure itself. What do we mean by gauge structure? This one is a gauge, stage gauge measurement staff. This is a staff. So it is showing you 3.9, 4, 4.10. So 4 meter or 4 feet above a certain zero level of the datum. So those datum should be linked to permanent benchmarks. So those should be selected in such a way that those should not be movable. Permanent reference points should be there. I mentioned, for example, bring in your mind a stream gauge location, a stream, and you mark 3 fixed points as your reference point, and from those 3 points, you know that your stage staff zero level has so much elevation from those fixed stations. For example, one station you have selected at the top of the road. At the top, for example, there is a milestone installed over there, and you consider that is a permanent milestone that is not moving. So you select that one as your reference mark. From that milestone mark, you can again correct the level of your stage staff if that staff has been moved because of some flood event or because of some reason, if stage have been moved. So if you want to select, if you want to reset it again, you can again carry out the survey, you can again carry out the leveling activity, and you can again set the zero level of your stage staff, of your staff over there. So you should have at least 3 permanent reference marks so that if you want to recheck the staff itself, you should be able to do it. Or if staff have been moved from its place, you should reset it again using those reference marks. The gauge datum may need to be changed if there is excessive channel scar. So again, same thing, scour and deposition do affect our stream gauging station. So if there is excessive scour or deposition occurring over there, then we may need to change the location of that stream gauge, or we have to shift the staff to other place so that we can measure the water levels. Why do we measure the stage? Because this stage is an indication, the level of the water is an indication of the discharge, because it is known to us that discharge is a function of the depth of water or elevation of the water. Discharge is a function of H. It can be depth or it can be elevation. So you should be knowing the difference between elevation and depth. Both are not same thing. Elevation is level with reference to are datum. Elevation is level of the water with reference to datum, while depth is the level of the water with reference to bed. So if the datum is your bed of the channel, then that is the depth. Then stage and the depth will be the same. But if datum is somewhere else, so then your elevation and your depth will be different values. So at one location, elevation of water can be 110 meter above the datum, but depth may be 1 feet or 1 meter above the bed. So both are different things. Depth and elevation you should keep in mind. Usually people mix them. They are they wanted to talk depth. They are mentioning levels. They wanted to mention levels. They're mentioning the depth. So you should be careful about this. Reliability in discharge record. So because discharge is dependent on edge, elevation or stage, and as I have told you, most of the time we don't measure discharge directly in the stream. We have the rating table, we have the rating curves available with us, and we only measure the H or a stage of the water at a certain day. Using that stage and using that rating curve, we estimate discharge. So if stage is wrongly measured, if elevation is wrongly measured, and for example, everything else is fine, that rating table was fine, and conversion is fine, then discharge will be wrong if H is measured wrong. So we have to carefully note the stage, we have to carefully note the level of water. So these are measured by in a systematic way, and we can have different kind of gauges for measurement of stage. Uh, Most of them are non-recording gauges. Simply a staff is installed and a person go over there. That staff does not record the level automatically. A person go over there and note the reading of that time or that day. So there can be non-recording gauges for stage measurement. There can be recording gauges. There can be gauges which only record the highest water level as observed during the last time period, during the last day. So the highest here the maximum elevation, we had the maximum temperature thermometer. So similarly, we have the crest gauges over here to estimate and to record the highest elevation of the previous time period. And there can be automatic gauges which continuously record the data. Few gauges which are frequently used in field. The most simple one is a staff gauge. Staff you have seen in the survey laboratory also. Similar kind of staff, a wooden staff or a metallic staff uh, with the graduation marked on it, that is installed in the stream, and the zero of that staff is linked to the datum. Zero of that staff is linked to the datum. So that is measuring elevation with respect to datum you have selected. Uh, uh, if you have selected datum for your project yourself, okay, fine. If you have selected datum from the mean sea level, then you should find some benchmark in the close locality whose elevation is known to you. For example, a permanent benchmark by Survey of Pakistan is there close to UET outside gate number 2 on the other side of the road. There is a permanent benchmark, so its elevation is known to us. That is linked to Pakistan Survey of Pakistan data. That is linked to the Pakistan triangulation network. So from there we can bring level to a station of close to our project, close to our stream gauging station, and then we can install the staff gauge accordingly. So one is staff gauge, one is the wire weight gauge, one is float type gauge, one is electronic type gauge. So staff gauges are simply the wooden or metallic pieces with the graduation marked on it. Graduations can be in meters, it can be in feet. And the standard staff gauge, which is recommended by USGS. USGS is what? United States Geographical Survey. United States uh, USGS. Anybody remember what is it? USGS. किसी को याद है USGS क्या बनता है? Okay. Nobody is listening. Nobody is answering. क्या हो गया भाई?
Sociological survey.
Geological survey. Geological survey or geographic survey?
Sir, geological survey.
United States Geological Survey. Okay, why everybody is so sleepy? जाग क्यों नहीं रहे? Why not somebody stopping me? Okay, States Geological Survey recommended a standard staff gauge. They say that it should be built. It should consist of porcelain enameled iron sections. So it should be made of porcelain, and its width should be 4 inch and 3.4 feet long. So one staff should be 3.4 feet long. If you have to measure more depth, so then multiple 3.4 feet staff can be used for measurement of the stages. And the least count should be 0.02 feet long and graduated every 0.02 feet every point. In SI units, it should be at about 6 inches, 150 millimeter, and length should be 1 meter, and should be graduated every 10 millimeter. So that is standard staff gauge. You might have seen such gauges installed on the pillar of the bridges, on banks of the channels. You might have seen it. If you go to bridge, Ravi Bridge, any bridge, Shadra or this Sakyam Bridge, you can see staff gauge installed over there. Sometimes these gauges are just marked on the surface. For example, over here, they are just marked on the pillar itself. This is the staff gauge he is holding, but behind that, simple marking on the pillar is there. So that also work in a good way. So USGS staff gauge in Corton on Muskegon River near Croton, USA के कोई figure है. So this is USGS staff gauge. This is the staff gauge installed locally at that place, and you can see the difference. Here is the staff gauge installed somewhere, I think, in Ravi River, I think close to Jasser. They have just marked over there and they are using it. This will work fine as far as this pillar is not settling. This staff gauge will be working fine as far as this pillar is not settling, or if the bed of the channel don't have excessive sediment deposition or erosion, this will be working fine. And this should be marked, this should be renewed. Their mark should be renewed every year, because with the passage of time, they vanish away, like they are faded away over here. So they need to be refreshed every year through the practices. Sometimes these staff gauges are not vertical, rather they are inclined. We are seeing over here in this figure, bank of a channel. There's a channel, this is the bank of the channel. So along the bank, in inclined position, the staff gauge is installed. Reason for this is it is possible that If they install a vertical gauge over here, then they are not able to go over there and read it over there. So if it is installed that is not stable over there, that can be the reason. So over here on the bank, it is more stable, it is getting support at the back. But keep in mind that the marks over here, which is 9, 10, 11, 12, 13, so they should take care of the slope effect. So it should not be simply equal to 1 feet length, rather it should be larger than 1 feet, so that when there is a vertically 1 foot change of water level, it should be showing over here the 1 foot change of water level over here. So an inclined staff gauge is used for an outside gauge and usually consists of a graduated heavy timbers securely attached to a permanent foundation. So you should feel the difference. If it would have been vertical, then 1 foot would be representing 1 foot. But 1 foot variation over here, 1 foot variation vertical over here should longer over here because inclined distance is longer. So that should be kept in mind if you are going to for the installation of an inclined gauge, you should take care of it. Sometimes we have sectional gauge installed. A number of staff gauges are installed and have the stage measured for a channel having a lot of variation in depth over the year. So we can install a number of staff gauges at suitable intervals so that once it is on high flood, we still have a staff gauge available for us to measure the level. And if it is at low stage, we still have a staff gauge installed, which gives us the water level. For example, if there would have been only one staff gauge over here of longer height, then you need a boat to go over there to measure it. But if we have sectional gauges like this, like shown over here, one gauge, second gauge, third gauge, fourth, and as many as you need, then you will be staying on the dry location. You will be staying on the bank of the channel to read water level. Uh, those gauges which are underwater, those will not be of any interest to you. Only that staff gauge which is partially underwater and partially above the water, that will be giving you the correct stage value. And all of them are linked with each other. 2 meter over here is 2 meter over here. 4 meter over here is 4 meter over here. So if we want to install a new, another one staff over here, so it's 6 meter will start from here and it will go up. So all of them are linked to the same reference surface or same data point. So here is the actual installation of the staff gauges, sectional staff gauges, 1, 2, 3, 4, 5, and so on. There can be many. So these are good when there is a huge variation of the water depth from the lowest water level to the highest water level. Then sectional staff gauges are required. When there is a possibility of silt or mud staff with this, like you have seen that you can mark the point on any surface, but a staff with a raised graduation, we call it beveled or paved staff should be there. It should have raised graduation on it so that even if it is muddy over there, still we can feel what is the water level over there. So during normal flow season, the gauge is read hourly. So how frequently we have to observe the stage? If there is lot of fluctuation in water level, then we need to have more frequent observation. For example, in flood season, we usually have in high flood season hourly observation or sometime made. While when there is very calm time, much fluctuation, 5 hourly or 8 hourly. Another kind of gauge is called as wire weight gauge, quite frequently used. We have a box which contains this wire weight gauge. a weight is suspended with the wire, and that wire is woven around a drum. A weight is suspended. You see over here this yellow color. This is brass weight made of brass, so that it should be corrosion protected because it has to stay in the open environment. So the weight is suspended with the wire, and the wire is wound around a drum, and the size of the drum is such selected that one circulation of this drum uh, release 1 feet of this 1 feet of this wire. So one revolution of the drum is equivalent to 1 feet depth of the wire. So they rotate this one, and it has a counter attached to it, so that we should know how many number of rotation are there. So it is installed at a certain permanent location like bridge over here. So when they have to measure the stage of the water, a person go over there. He release the weight. When the weight touch the water level, the number of revolutions of the drum are noted, and that will give them the idea how much is the level of the water. For example, over here, over this bridge, this wire weight gauge is installed. When it is touching over here, they measure how much is the wire length over here. They measure H over here. So if they know the elevation of this instrument itself, if they know from the datum elevation is G, and they have just measured H, so they can have the idea of capital H, that is the stage of the water level. So capital H will be the level of this instrument minus the depth of the water from the wire, from the bridge itself. So that is small h. So capital H can be estimated. Stage can be estimated knowing the depth of water from this instrument. So that is usually used in field also. This is another figure for the same. While it is not in use, it is covered with the box to protect it from the corrosion or damages. So the wire is wound around it. Just one cycle of the wire is over there. It is not duplicated. So for that purpose, this wheel is moving left to right. So that there should be constant length of wire for one round of the drum. So usually wire thickness is very thin, 0.045 inch cable is used to suspend the weight. One revolution covers 1 feet of the wire, and mm, that is it about wire weight gauge. Sometimes we suspend them with the help of the cantilever installed to the bridge pier on the side. Not bridge pier, some permanent installation on the side. We can install a cantilever a frame like that, and we can install our instruments with that one also. And another kind of staff measurement is float type gauge. Uh, it has it is usually installed in a stilling well. So what is a stilling well? Close to a channel, we can make a well-like structure made of concrete or masonry, and we can connect that well-like structure or a room-like structure with the channel itself. So whatever will be the water level in the channel, same will be the water level in this well. But what will be the benefit is that the fluctuations which we can see in the channel, and the debris which can affect the channel, so they will not come into this stilling well. So we will be having relatively calm water in the stilling well, and we can observe the water level within this stilling well. So observation can be either through float gauge, either through simple staff gauge. Method of observation can be different, but these stilling wells are frequently used. For example, I show you stilling well. So over here, here is a channel coming over here. A stilling well has been installed over here, and it is linked with the channel itself. So whatever is the water level, same is the water level in the stilling well, and it can be observed easily. So if a float type of instrument is used for estimating the stage, it has a light material like a float, usually an empty plastic drum is used as a float, and on the other side they have a counterweight, and they are linked with each other through a pulley installed over there. So as the water level go up or down, because the weight of both is balancing each other, the water level can move this float up and down. So as the float goes up and down with the change of the water level, so the dial on the pulley also changes. So from the dial reading, they can note how much is the stage at a certain time, at a certain location. Uh, this float type of here is actual float gauge. On one side they have the counterweight, on other side they have the hollow float. They are passing over a pulley. As the float will move up or down, the dial on this either the dial on this will give you the reading, or the rope which is connecting this counterweight and the float itself is nothing but a tape itself. So this tape reading will tell them what is the stage, what is the depth of water at the moment. So this string can be replaced with a tape. So over here they are showing that a tape is being used. Steel tape is being used for estimating the stage at a stream gauging station. In addition to this, sometimes they use electronic instrumentation when this float or this weight connects the water level. A circuit is completed and a signal is generated over here. So then they know that at the moment the float is at the water level, and they note what is the tape reading at this location. So this can be used for very deep channels where they cannot see whether the float is in touch with the water or not. So to know whether the float is in touch with the water or not, they use electric circuit. They have a battery installed with it. One side is grounded and the other side is connected with this weight itself. They release the tape. When the weight come in touch with the water, a circuit is completed, and this voltmeter will show different signals, and then they will note the tape reading at that time that this is the stage of the water. So this is electronic instruments which can be used to estimate the stage. Voltmeter and a battery arrangement is available just to know when the conductor or the weight touches the water. So when they know that it is touching the water, then they note the tape reading over here. Float type gauge installed in the Stirling well, I have already explained to you. And Stirling well is important. We have to take care that Stirling well connection should not be choked. Second thing, we have to take care when we are constructing a Stirling well that its depth should be lower than the lowest depth of the river. If the lowest depth of the river is over here, its depth should be even lower than that, because some sediments will come to this Stirling well over here. If there is no room for deposition of those sediments, then this link or intake will be choked. So for to avoid choking, when this will be choked, it means water level over here will not be conveyed to the Stirling well. Water level over here will be different than if these intakes are choked, then water level will be different. So because we want to measure the water level in Stirling well, and it should be same as the water level in the river, so this intake need to be clear all the time. We can have multiple intakes, one at lower level, one at higher level, that's possible. So we can have different kind of measurement instrument. It can have a float type of instrument, it can have a simple staff gauge instrument, and these are usually used. Stirling wells protect the gauges from floating debris. One of the benefit of Stirling well is no debris will come over here. No waves will be there. They are made of different kind of material, concrete, masonry, aluminum pipes, different. The stilling well should be deep enough for its bottom, already informed to you. Uh, they should be sufficiently high enough so that the highest flood expected over there, at least 1 in 50-year flood, should be accommodated within this sealing well. It should not be overflown for normal floods, which comes every 2-3 years. It should not be overflown. So it should be sufficiently high enough so that flood, which is expected once in 50 year, we call it a flood of 50-year return period. It is that flood which is expected once in 50 years that should also come within this, within the depth of this well. Here is actual stilling well installed over here, and it can be having many other instruments. For example, nowadays steam gauging station are provided with the telemetric data transformation, data communication mechanism. So here are the antenna attached to it, so that whatever is the data recorded over here, that can be conveyed to the headquarter, that can be conveyed to the meteorological station or headquarter of the hydrological observatory. So here is a connection of actual stilling well with the river. So if it is above, if the stilling well connection is above the water level, it will not be showing you the correct water level. So the connection should be at lowest possible level, which the water which you want to observe. So this will not be giving now the information. Maybe when water level goes up, then this intake will be effective. At the moment, this intake will be effective if these openings are open. If these openings are clogged or closed, then water level will not be going into the water will not be going into the stilling well, and stilling well will not be giving you the correct observation. One kind of stage gauge is crest gauge. It measures the highest water level observed in the last time period. It consists of a vertical it is a vertical piece of 2 inches galvanized pipe containing a wood or aluminum stuff. So it is nothing but simply a pipe is installed, and in that pipe there is a staff installed. Staff is placed inside that, and at the bottom of the pipe, at the bottom of the pipe, there is some light material is placed. Some grounded corks are placed. Let me show you the figure of it first over here. Uh, it is simply a pipe, 2-inch diameter, with the holes at the bottom from where it can get the water into it. At the bottom, there is a container which contains some light material like corks or some thermofoam. So small pieces of corks or thermofoam which are placed inside it. When the water level rises in this pipe, this stuff will be inside it. When the water level rises inside it, then these corks also rise upward. And when water level will go down, the highest level which has been recorded by by this stream, that will be shown by some of the corks which are stick to this staff gauge itself. So some of the corks will remain stuck to the staff, and that will represents what was the maximum level observed during the last time period. Got it? So cross-sectional view of that. So they have only simply a pipe installed over there with the opening on the sides. A staff is available over here. Some corks or grounded corks will be there, or some light material will be there, which can become afloat with the increasing water level over here. Because the purpose of this crest gauge is to measure the maximum water level. So when the water level is at its maximum stage, so corks are also going up. So when the water level goes down, some of the corks will remain stuck with the stuff. So when next day we go over there, we take out the stuff out of this crest gauge, and we see what is the maximum level at which the cocks are stick with it. So that level will be the maximum level observed in the last time period. Okay, it's fine. Hopefully you got it. So this is used to measure the maximum water level in the last time period. So I stop it over here. So there are some figures available of actual staff gauges installed and some of the structures I have visited in Pakistan. I think this is Chashma, Chashma Barrage. On the side bank of the barrage, they have installed these staff gauges. Within a stilling well, they have installed this staff gauge, and condition of the stilling well was very poor. I think it was choked, and they were not using it for measurement anymore. Another view of a staff gauge. I think this is some canal from the Baloki, maybe. Yeah, this is Baloki. They have the stilling well over here, staff gauge over there. In addition to that, they have installed automatic water level recorder. They use the sound waves to estimate the depth of the elevation of the water with respect to this instrument. So they have auto stage recorder installed over it, which conveys information to the central telemetric system. Here is a barrage, and on the pillars of the barrage, okay, here's the barrage, and you see a water level sensor installed over here from with a cantilever is there, and this instrument is there. With the help of the sound wave, it measures. At the background of this, you can see the staff also there. The marking of the staff gauge is also there at the back of this. So that is actual. This is a close view of that one. That was close view. Here is the float gauge. I think this is also Baloki. So a wire, one side is float, another side is the counterweight, and this reel will tell them the water level. This is Sakhar Barrage, and they have staff gauge installed on a pillar. They note the water level through this staff gauge. These are some of the dials for recording of the stage variation in the canal. So thank you very much. If you have any questions, you are welcome. कोई आपके questions हैं तो welcome. This is the first part of stream gauging. Today we have just seen different kind of the staffs, recording, non-recording, float type, crest gauges. Next time we will be seeing how to measure the discharge in a channel using current meter, and how to estimate, if you have the current meter readings with you, how to estimate the discharge in the channel, how to compute it. Okay, so I stop it over here. Thank you very much.